are you looking for a tutorial which will help you to create some pathfinding using Gamemaker drag and drop code? If so, this is the tutorial for you. This is part of one of my iMedia tutorials, which I run online at teachallaboutit.uk. And if you'd like to join me for the full course, please go and have a look on my website. For now, let's go and have a look to see how we can take these objects, find out where they are, and go and collect them. So we're going to start off by creating our objects and our sprites. Now, I've created 4 sprites down here. I have a collectible. This is going to be my little spider who's running around my screen. I have created the walker object. Now, the walker object is going to be a little bit like an enemy. This is the thing that is moving around and actually trying to get to my collectibles. Now, in this particular example, I haven't added my player yet. I've also added some walls. These are just basic squares which I have placed around the edges to create like a game area, and also some obstacles. And then I've also created a set of obstacle sprites. Now, these are just placeholders that represent some of the objects that I might have in my game room. I've then created each one of these as an object. So you can see the sprites are just the images, and then over here we've got the objects, and you can see I've got 2 extra ones. I have all of my wall, my walker, my obstacle, my collectible, but I also have an object of game and an object called controller. Now, these 2 things actually do very specific items. Now, my object of game is an invisible object which is going to create the paths that go around my room, and I'll show you how I do that in a second. The object of controller is a little bit like a spawner, and if you've ever played Minecraft, you've probably used spawners. The controller is creating all of my collectible objects. So if I have a look to start off with in my room, you can get to your rooms down here. There's always room 1. You can see here I have created my room already. Now, my controller object at the moment isn't actually spawning anything. It's not really doing an awful lot, but it will do later. This here, I have my instances. Now, my instance is where I have my walker. I have an instance for all of my obstacles, which is where these have been placed. And it's also where my walls are. Oh, no, it's not. My walls are in a separate one. And that is just to place them in different places. So you can see here, my instances has the walker and all of my little collectible objects. So now we have everything there. We're going to go back into the workspace. So there is my workspace, and what I'm going to do is I'm going to walk you through some of the events I've needed to create. So the first thing we're going to do is to go to that object game over here. Now, this is that strange object that you saw as just a little question mark, and you won't actually see this in your game, but it creates a lot of the code. So I'm going to come up here to the create event. Now, if you're going to add one of those, you go to add event and then create. This is when the screen is started. There's a lot of code in here, so I'm going to walk you through it step by step. Just pop those over there, and we'll just make that a little bit bigger. So here I'm going to set a global variable. Now, a global variable is one that can be seen for every object in the entire code. So global means that you can see it and access it and change it no matter which object you're using. And this is called game grid. Now, game grid is going to be our variable that shows a grid over the top of our game screen. We're going to set up 3 variables after that. You can see here I put some comments on the side, and adding comments to your code, really, really good idea, because future you will thank you. Now, to add a comment, right click, and you can just click on comment. So we have cell size. Now, I'm going to stick with 16 for my cell sizes. Usually I use powers of 2, and I try to set my game sizes in powers of 2 as well, because that then relates to screen sizes. Cell size of 16 is okay. You can always make it smaller or bigger. If you want it to be more accurate, you make your cell size smaller, and bigger if you want it to have a little bit more free flow. So the size of each square in our grid is going to be 16 pixels. Then I've created a cell width. Now, a cell width is actually like the room width, and it's going to be the cell size, 16 pixels, times 30. Now, you might need to do a little bit of tweaking, see how far or how big you need your grid to be, but 30 for me was pretty accurate. Because I'm doing something which is landscape, my cell height is then cell size multiplied by 20. I don't need it quite as big. So you can see here I've got cell size. I was going to have X start and Y start because that was the beginning of the coordinates, but actually I found I didn't need it. So I need to edit this over here. And you can see you can just go in and delete it. I've used the word map, but map is a grid. Now, once you've created your variables for setting the size of your grid and how many cells you have in there, you need to do a function call. Now, this function call, I'm going to go in a little bit here so you can see it properly. Maybe not that far. It's not very easy to read. There we go. Now, the function call we're going to use is mp_grid_create. Now, this exists in both drag and drop, and it also exists in the standard script. However, in drag and drop, you write the function name and then you do all of the arguments. You might know these as parameters. These are the pieces of data that we're passing in, and these go into the next one down. So we're going to give it 0, 0. This is where we're going to start. So 0, 0, top left. We are going to say, place our grid for the whole of the cell width and the cell height. That's how big our grid is, cell width and cell height. Then the size of the boxes inside, so the cells, are cell size and cell size. That, again, that is the width and the height. You don't necessarily have to have squares inside your map. It does make it a little bit tricky if you don't, so I would recommend, if this is your first pathfinding, stick with squares. So that's all the data we're passing in. Then we do another function call. Now this function call is going to be mp_grid_add_instances. This is saying these are all the things that I need to be aware of in my grid. Now that means for me, I've placed obstacles. So you saw those little circles with the triangles and exclamation marks. Those are things to avoid. In a real game, that might be walls, or could be trees. It could be anything that you don't want to be able to just walk straight through. These are the obstacles that we need to add into our grid. So here, global.gameGrid, this is the grid that we are using. Remember, it's global, so every object can use it. Don't allow object obstacle to be walked through. And then a true. Now, true is there because we have more than one. So you can see there, true means precise, false is basic. That's like the whole square. So because I've got circles, I've used true to make it a little bit more rounded. If you want it to just be nice and basic and you want to save a little bit of memory, you can put false in there. Now that is going to create the whole of our grid. Now if we go back into room 1, you can see there is our object of game. So what happens is when we run this, you'll actually see a grid. So I'm going to run this and show you how that would look. Be aware though, obviously I have the extra code there for moving. So this little section here where you can see the grey area, that's my grid. You can see all the grid paths there. And those are my 16 by 16 squares. I can change the colour of this if I want to. If I go back into my workspace, and that happens in the draw. So I've created it, but unless I have this draw event, again, in the object game, I'm not going to be able to actually see what I'm doing. So here in my drawer, I need to set, so remember we've used draw GUI before. This is an add event, draw, and then just draw. So I'm going to set my draw color. I'm going to set it to red. I am using alpha now. Alpha basically allows you to have transparency. I'm going to set that alpha down to 0.1. I'm going to actually change it to 0.2 for this one so you can see what I'm doing. Then I'm going to call a function called mp underscore grid underscore draw. Now the reason I am calling that is so that you can see it on screen. Later on I will remove this because I don't want to see it. So the actual path will show up as red, and that grid is going to appear on screen. Then after I have finished with it, I'm then going to send it back, the alpha set back to 1, because otherwise all of my objects will be weirdly transparent. So let's save that and run it again. There we go. So you can see the transparency is there, and there's my lovely line. And all of these areas here, you can see are covered in red, and they are objects to avoid. And that's why my little person went all the way around the edge. So these little squares here, they are there specifically to say don't go around this. Now you can add in the create, you can add as many instances as you like. If I wanted to add another wall, say, I might go into here. Let's go into, I'm going to go into my obstacles because I want to make sure everything's in the same place. I'm going to add this box here. So let's put a little line along there so you can't go through that. So this one here, I now need to add an object of wall into this one as well. So I would need to add another function call. I'm going to try and make it the same size as the others because I quite like my code to be nice and neat. You can do mp underscore grid underscore add underscore instances. Now you will see it in there. You can also double click and just get rid of the brackets. Do get rid of the brackets though, because we need to put the arguments underneath. We are going to say we're adding this to global dot game grid, and I want to add my object of wall, which is obj object underscore wall. This one's going to be false. You can just get the whole square, that's fine. Just avoid it. So now if I run this, what you should see is that little red section. You can see there's red all the way around those walls. And because this side here, the square goes up to here, it will also avoid this one. This part here, you're not actually seeing the red because it is on an instance which is too high. So that's fine. That's being avoided. It's going around it. It's not going to go through. There we go. And all the way around. Now, how do we get them to go round? Let's go and have a look. So set up our grid. We've been able to look at our grid. Now we actually want our walker to do something. So let's go have a look at our object of walker. So this would be your NPC. And we have a few things on here. Firstly, we have a create. So when everything starts, we are going to do one thing. We are going to call a really important function called path underscore add. Now, path underscore add is going to create that path. You saw that line going from the walker all the way to the next object. Well, this is what we're doing here, is we are creating a generated path. We're calculating the fastest place to get there, and we're going to save it in a variable called path. You can call this anything. You could call it Fred, as long as you keep using the same name. However, try and make your variables meaningful if you possibly can. So when we create it, we just create a path and that's it. Then in the step event, this is where it gets complicated. So again, I'm going to move this across. Let's expand this a little bit and we'll look at each bit in turn. There we go. So the first thing we're going to do is we're going to work out how many instances there are of our little creepy crawlies on the screen. Now we're going to do this in the step so that what it does is it looks for it every time the screen refreshes. So if you have a game that is 30 frames per second, this will happen 30 times a second. This is going to look for, in my case, object collectibles. That's what I've called my little spiders. And it's going to save the number of them in a variable called num collectibles. So this is how many little spiders I have on the screen. Then I'm going to put an if statement in there. So if the number of collectibles on the screen is greater than 0, then I want to calculate my path. If the number of collectibles on the screen is 0, we're done and we want to finish. We don't want to try and create any more paths. We want to keep the memory nice and secure. There's nothing left to go to. So if we do have something to collect, we're going to call a path underscore delete function. What this does is it takes the current path, gets rid of it, and it recalculates the most efficient path to our object. So it's not like it goes, right, here's my path, I must stick to it. It will constantly recalculate the shortest path. And this is really helpful if you have those collectibles that are going to then start moving. So path delete, I'm going to delete my path. Then I'm going to assign a couple of variables. So I want to get my target of X and my target of Y. This is where I want to move to. So I go to target underscore X, that is a new variable that I've created, and object underscore collectible, which is my little spider object, dot X. So an object has lots of attributes and X is its current X coordinate. So if you put a dot on, after an object name, you get lots more values that you can use from it. So in this case, my target, my X target, is the collectible, so my little spider, it's that X. The Y is also the spider's Y. So 2 assigned variables. Now you can do this in 2 separate blocks, or you can press the plus. Either one's absolutely fine. Once you set where you want to go with an X and Y, the next thing to do is to call path underscore add. We just deleted a path and now we're going to create a new one. And we're also going to call this path. So it's just recreating path. Think of it a little bit like a whiteboard. You've just wiped all of the data off and now you're writing it back on again. We've got one more function call to do, which is MP stands for make a path or map path, underscore grid underscore path. So this is basically calculating where to go. The arguments for this are put it onto our global game grid, which we created a minute ago, calculate using the path that we've just created, set my object's X and Y coordinates using the target X and target Y. So go from A to B, X and Y is A, target X and Y is B. So those are your start and end points. Finally, I've got a 1 at the end. Now 1, you can see here, 1 allows you to ride that path. You saw that, that line, and you allow it to be diagonal. If you put 0 there, it has to move only up and down. Diagonal's a little bit more complex. And then finally, we want to start following path. Now start following path, we want to follow path because that's what we called it. I've put speed 1 so that it's nice and slow and I can track that it's actually working. You can change this and the higher the number, the faster it will be. When we end, we're going to put a path underscore action underscore stop. Now, what basically that means is that our NPC will stay still until it's told something else to do. And finally, absolute must be false if you've got more than one object. If you just want to do this once, keep it true. False is really important if you want to keep it and go and recalculate the path. So there we go. Every second, or every 30 times a second, we are going to find the number of objects. If there are objects to collect, delete the current path, work out where we're going, create a new path, and go and follow it. In order for us to actually see what's happening, we're also going to add an event. And that event is a draw, GUI, or GUI. Again, this is probably not for your final game, but this is really helpful for when you're testing. So in here, I have a draw values, and I am putting in a caption of collectibles and the value of num collectibles. So if you remember at the top of the step, we got our instance count and saved it into num collectibles. So how many there are left. And that's what we're going to do there. And specifically 20 pixels across from the left and 20 pixels down. So it's not too far. It's not sort of in the wall. I'm going to output that to the screen. Then I'm going to set my sprite and I'm going to call the function draw underscore path. What this does is it shows it what path it's following, the current XY coordinates, so you're not showing the original, it goes all the way along. And again, same thing with one, showing the diagonals. So what this does is that draws that red line on the screen, and it's showing me where I'm going to end up. This last one, you could actually get rid of that at the end. This is terrifically helpful though if you are in the middle of coding and you actually want to know what path you're following. And finally, when I collide with one of my little spiders, there is one more thing to do. When I collide with a spider, or in this case an object underscore collectible, I need to add a new path. Now what this does is it says I have collided with my spider, now go and get the next path, go and move on to the next one. This is incredibly important. If you don't have this, it won't then work out what the next path is. So before we can do that, we need to be able to collect our objects. So we're going to go to the object collectible. And in here, I've got some bits and pieces on here, which will allow them to move. At the moment, I've switched those off. So my collision with an object walker, I'm going to set the index to 0 and destroy the instance. Now, index of 0 will be to allow me to create a list of who has been collected. This comes in slightly later, but you want to destroy that instance so it's no longer there. So running this, you can see it's calculated its path, and if you look really carefully, you can see as it's moving along, especially along around the objects it's not allowed to touch, you can see that path kind of wobbling. And that wobbly path is because it is recalculating the path each time it moves. So this one here, it's not going to go through the wall, it's going to kind of go along the wall, recalculating to try and get the shortest path. There's only one collectible left at this point, and straight down we go. And because there's nothing left to do, it's now going to stay exactly where it is, and this part of the game is over. So there you have a full tutorial on how to add your objects onto a screen, create a grid on your screen, and use that grid to send a non-player character around towards the path of another object, but also for multiple objects.